Gavor. Today we're going to talk about Chapter 11 in the Wallace book, System Development and Procurement. Next week we're going to talk about project management, and these two really go hand in hand because any significant system development or software system development is really a project and should be managed as such. So we're going to talk about the system development lifecycle. SDLC, as a book calls it. I was not familiar with that acronym, but I am now. We're going to talk about software development strategies, the selection of strategy, which strategy you should use, build versus buy. Do you write your own code, or do you buy an existing package and adapt it? What's the human element in all this? Because, we're really talking about a socio-technical system. By definition, a socio-technical system is a human machine or technology interface. It could apply to manufacturing technology in a factory and how human beings integrate with that to produce products, or in this case we're talking about man and IT interface. So the amount of planning that you do makes it more successful or less. If you spent 30% of the project planning, or 10% of the project planning, this is probably a better example, and then 90% of the project actually writing code and doing and implementing and all of that, your project will probably take longer and be less effective than if you spent 30% of your time planning and then 70% of your time coding and doing and implementing. Now that might be two extremes. The reality is probably somewhere in between. But you get the point. If you plan, the better you plan, probably the less time overall it will take, and the more effective your initial implementation will be. And part of the lag, if you don't plan enough up front, you end up doing a lot of rework after you've implemented, and that can be very costly and drag out the project maybe up to twice as long as you wanted it to take. An example would be Facebook was pretty well planned out and grew very quickly because it did what it was supposed to do for the audience it was supposed to do it, for the user base it was supposed to do it. And you saw the phenomenal growth in just one day. If you watch the movie The Social Network, very interesting movie, I recommend it. On the other hand, there was a project at the FBI that they scrapped the project after spending $170 million because they didn't plan it out properly. So here's a soft systems development lifecycle. It's planning, it's analysis, it's design, development, testing, and implementation, and finally maintenance. And we're going to talk about this in a little bit more detail. The first thing is, for most systems, I would say that this works. Let me fix that a little bit. And I would say also that you've got to establish a team that does this. And it might be a small team, if it's a small software application, or it could be a very large team if you're talking about an ERP system for the entire business. And it should have business members from the company. It should have IT and IS members from the company. And perhaps it will include contract workers in the IT and IS field. And it may involve the software provider if you're buying the software. More often than not, and I'm very serious about this, the project has to be viewed as a business and not an IT project. It is not an information technology. It is not an information system project for most business applications that I have seen. And therefore, it has to be business-led. They're the ones that have to use it. They're the ones that are paying for it. They're the ones that have to define what they want to do with it and what they want the software to do. Now, the IT people are a very close second to this and have to be a very good partner. But IT people want to put in slick IT packages that may not have the application that the business people want. So this is an important lesson I think you should heed here. Okay, so if we look at planning, You have to have a return on investment. No one wants to do this if there's not a return on investment. And many companies have very strict ROIs. They want it to pay for itself within 18 months, 12 to 2 years, 12 months to 24 months, 1 year to 2 year, and 18 months might be an average, at least when I was in the industry. They want it to provide some sort of competitive advantage, if possible. And they want it to either mitigate an existing risk, or they want to make sure that you're avoiding a future risk, perhaps, by doing it. So you want to assess the business need. What is a business need? You can't get anything like this approved, especially if it's going to cost significant money. And significant money might be $50,000 at some companies. It might be $1 million at other companies. And how much does it cost to implement an ERP system across a multinational? That's multi-million dollars. Then you want to do a feasibility study to find out what is it that we have, what do we want to do with it. It takes the top level assessment of return on investment and those benchmarks of competitive advantage and risk management and explodes it out to maybe another, a larger level of detail. Okay, now you got my attention, we could get this kind of return on investment, we provide us a competitive advantage in this regard. What's involved in doing this? Why do we have to do it? What's the scope of this project we're about to embark on? Then you do some analysis. Here's one where they did, just a customer visits website. Is it a new account? Yes, prompt user to create a new account. If it's no, customer selects grocery products available from the database. A system retrieves matching recipes and near matches, and output displays matches and coupon for products that are missing. I don't know if that's an analysis or not. That's a flowchart of what you want it to do. But you want a process diagram. You want a requirements definition document. There's a very good one, a little table in the book that summarizes that. It's on page 333, and it's basically called the types of requirements included in the requirements definition document. You want the functional requirements, the usability requirements, which is the ease of learning the software and all that human interface stuff. Accessibility, can people with disabilities use it? One of the things when we move online that we have to worry about, what if there's a deaf student and you have a video? You have to have subtitles. What if it's someone's looking at it from a different language? Can they add subtitles to the videos in your course? Performance requirements. What do you want it to do? What's the response time? The availability, scalability, interface requirements, security requirements, compliance requirements, integration requirements, and language requirements. If you're a multinational company, is everything done in English? Or do you have to have it in the local language sometime? Do we build our own software? Do we make and code our own software? Or do we buy an existing software and adapt it? One of the things that I think is important part, it's exploding on the process diagram, is something I call the as is to be analysis. You need a detailed flowchart of how you currently do things, whether it's a computer system or by paper. And then you want a to be analysis. How would we like it to work in the ideal future scenario? That's got to be part of your process analysis and diagrams. Okay. Design must build around the to be process. And you have to have, in doing that, you want that to influence the architecture of the software that you want to do and how the kinds of depths and data and organization of the data that you want. If you don't do this right and you end up with data that's not quite exactly what you want, and that's usually in the analytic portions of it afterwards, you have to go back and restructure that. It's very expensive. So you want to do it right up front. This whole idea of better planning, I will emphasize that all along. Then you have development. You want to have version control. Well, first of all, you don't have a version until you start actually coding it. Then you have a beta version. And you could have beta versions 1, 2, 3. You want to keep track of where you are. It's like if you're doing a big contract or you're doing a large business plan for a company. It could be 50 pages long. You have to have a good way of tracking, even if it's a Microsoft Word document that 10 people are working on, what version are we looking at? What's the latest revision? And there's ways of doing that very well. You want to make sure that you look at this and run it like a significant project and track all of your issues. You want to make sure that the code, as it's written, is reviewed and tested. You want to do all the quality control testing on it. One of this diagram they have out of the textbook is from a company called Atlassian that is very good at tracking IT kinds of projects, especially smaller projects, and keeping everybody on task on what's been done. So there's ways of commenting on it. There's ways of saying, here's the status of this right now. And actually at North Park, we use this for the Center for Online Education. Uses it when they're bringing a course online as a way of communicating people that are working virtually in different locations. Testing. So you have unit testing, system testing, stress testing, parallel testing, integration testing, and acceptance testing. Unit testing, programs can check the functionality of small modules of code while they're developing it. System is both end users, and IT staff test the functionality of the entire system. Does it do what it's supposed to do? And for something like SAP or Oracle, these things are well plotted out. Stress testing. How well a system performs under peak loads. That's another thing. Do you have the bandwidth? That's one thing we asked when everything in North Park was going online. I asked an emergency management team meeting, do we have the bandwidth to be able to handle the peak periods? And they assured me, of course we did. And I asked a couple more questions. I wasn't entirely sure, but I think we're doing okay. Parallel testing. So you want to see how it's operating versus your current system, or what we now call legacy system, which means a system that you're about to replace. Does it yield the same results? Does it operate faster? Hopefully it operates faster. Is it more effective? Is it more efficient? Integration testing. So you have end users and IT staff. You look at the interfaces with other software components it's linked to. One of the easiest things you talk about in new software, can it link on to SAP? Can it link on to my computer-aided design or computer-aided engineering? And every software developer, every software vendor or supplier, the answer to that question, yes, it's a seamless bolt-on. Well, in my experience, it's not always a seamless bolt-on. So you have to do that integration testing. And then finally, acceptance. End users perform final testing to determine whether it does what it's supposed to do. Somewhere in there, in between, you've got to train the users if it's significantly different than what they're used to. People get very fixed on these things. An example of where maybe testing wasn't done well. We implemented self-service for advising. I'm shocked by the inability of our students to actually do the self-service part. They still need me as an advisor. Professor, which courses should I take? Really? Well, it's because we didn't train well, we didn't have the right videos, we didn't involve the student base in the launch of this thing properly, and therefore we're still suffering with people not actually being able to use it to its fullest potential. Well, implementation. It can be parallel, phased, or direct, and if it's phased, it could be in two different ways phased. Parallel means you launch the old system while the new one is running. I'm not sure I've ever seen that done. Maybe you need to have it for like air traffic control. Maybe you need to have it for government security systems where the Department of Defense is involved. You've got to make sure that you've got them both running parallel, but you don't necessarily switch over to the new one until you're guaranteed that it's going to work, because you don't want to have 12 hours without a missile defense system, for example. That's the only thing I can think of in that regard. Phased, it could happen two ways. You could do it phased geographically, where you implement the full system in country 1, and then you implement it in country 2, 3, 4, according to some schedule. When the one SAP implementation I was involved in, it was in the Latin America division of Colgate-Palmolive. We implemented it in our smallest country first, Uruguay. And it took a year to get it done. By the time we got to the big boys, Mexico and Brazil, we were able to implement it in 3 months. But we wanted to make sure we got it right in a small country where a service disruption would be easily absorbed and weathered by the organization. You don't want to start with your most profitable subsidiary, which was Mexico at $1 billion in sales, and fail. So that's why we did it. We phased it geographically. The other way you could do it is phase it within one geographical one. If you have one implementation only, maybe with an ERP system, you go with general ledger and order management. And then you add HR, then you add manufacturing planning, then you add forecasting, then you add warehouse management, transportation management, quality management, all these other things. That's another way of phasing it. And direct, you switch off the old and you turn on the new with all the functionality of the new one. Now, direct is usually the way you use smaller applications. Like if I'm just implementing one of those phase things, I do it directly. I mean, let's say I have some sort of legacy warehouse management system, and I'm using now SAP's warehouse management system. Well, I'm going to do it direct. I'm going to switch off the old one. I'm going to turn on a new one. And in all phases, even if you're putting in general ledger and order management, you run your old system until a certain date. And at midnight that night, you turn on the new system and you're using that. And you try to make sure that you have a minimum number of orders. Maybe you do it over the weekend where there's not as much activity, blah, blah, blah. But there's many ways of doing it. I've only seen mostly phased and direct. I haven't seen a lot of parallel. Maintenance. I've added something here too. Because one is user support. They didn't include that. We want to do bug fixes and change requests and all of that kind of stuff, sure. And you want to manage the aging of the information system. Things get out of date. There's new versions of it, of course. Everything is almost versioned now and keeps updating, sometimes seamlessly. Sometimes IT needs to be involved to make that happen. But it's the bug fixes and the change requests that drive the versions, often. Okay, user support is also important. Because remember, it's a socio-technical system, people interfacing with technology. So there have to be reports. And most of the time, people think this darn thing doesn't work right because they're not getting the reports or the information in a way they used to get it and used to see it. So that's something that you want to address. And then there's something also, there's a power user. What's a power user? A power user is the person in your department or in your area when you don't know how to do something on a system, you go ask them. And I've seen organizations where, the power users in a legacy system all went away when the new system came on, and it took a long time for the new power users to establish themselves and be developed, and it happened organically. But I think what you want to do is always make sure that you're constantly training people so you can shorten that learning curve to make people just struggling users and become power users that can then help people in their own department. A lot of times IT people overlook that, and I think it's a mistake. So the development strategies. The first one is Waterfall. Well, it's this graphic that we used earlier. Oh, look, it looks like a waterfall. You do planning, then you do analysis, and you don't do the next one until the first one's done. And you don't do the next one until the first one's done. Well, I don't know of anybody that strictly ever did it that way. because the iterative way makes a lot more sense. You can be doing things simultaneously. You could be doing your planning. Notice how big the planning is bump up front, but it should never go away. In fact, it shouldn't be that close to zero. There's always planning involved, because guess what? There's always going to be changes and unforeseen circumstances that force you to have to plan on an ongoing basis. Your analysis probably starts at the same time as planning. And I would say it doesn't start at zero, probably starts a little higher. Because you started the analysis and planning even before the project was approved. And then it peaks out somewhere here, but the analysis keeps going on too, because if you have issues with planning and unforeseen circumstances, you're going to have to analyze those as well. Planning and analysis go hand in hand. Then the design. You design it, but you keep designing it. And it doesn't stop, even to go live. It doesn't go to zero at go live. Most people might think it does. Development for sure keeps going. It keeps going the entire length of the project. And then even when you're doing maintenance afterwards, you're still doing some small development work. The testing, this is probably accurate. It probably starts here and keeps going and well throughout the implementation. Go live, they have a star there. You want a specific date. And then you have all hands on deck for a go live. And then you have what they call system stabilization. When do you declare success? And then close the project formally. And then move on to a maintenance. And then we have something called Agile. Agile is a term that's used a lot today in project management and software development, which are closely related because most software development is project management. So Agile software development. Development strategies that involve cohesive teams that include end users and in which many activities occur simultaneously rather than sequentially to accelerate delivery of usable software. That's right out of the textbook. Scrum is an agile process for software development that relies on tightly knit cohesive teams that do sprints of 2 to 4 weeks each. So you think of a scrum like in a rugby match. And then they have something called extreme programming, a team-based agile method that features frequent releases of workable software, short time boxes, programmers who work in pairs, and a focus on testing. Okay. Well, I don't think you do project management at any level now without Agile, and Scrum seems to be a bona fide methodology that people employ. It's not just a concept, it's a methodology. And people actually get certified in it so they can run these things and keep the energy levels up. If we're talking about comparing approaches, well, it's dependent on the type of project and it depends on the organizational culture. Are we buying a customized system, or are we going to develop our own customized system, or are we doing prepackaged software? Well, it really depends what you're doing. Like again, the type of the project and the culture. If you're doing customized, the pros against it, it's tailored closely to the organizational needs. May differ, offer some strategic value that provides a competitive advantage. Maybe there's no software out there that actually does what you're trying to do. So you have to use custom. And if it gives you a competitive advantage, you're going to guard that software with your life. And it may not require employees to change their business processes. I don't know. Yes and no on that. Cons, usually has higher overall costs, definitely. Requires more time before going live, absolutely, because the cost and time and costs go together. You're paying for coders, you're paying for development time, you're paying for testing time and people. So requires ongoing in-house maintenance. If you customize something, you're responsible for the revision changes yourself. I mean, here's an extreme. I have a software that I have a unique way of forecasting for my particular business that's I've developed it ourselves, I want to program this application myself, and I don't want to share it with anybody because it would be a competitive advantage to me. It provides more accuracy somehow. Wow, let's do a custom project for that. We need a word processing software. Let's develop our own. We're special. Our company's different. We need our own word. No, you don't. At that point, go out and use Microsoft Word, or use Google Docs, or use Apple Pages. There's no need for any company to develop their own word processing software that I can think of. Okay, prepackaged softwares. Handles processes using industry best practices, requires shorter implementation times, carries a lower cost, and you can include vendors' new features and maintains compliance and keep the compliance requirements up to date because the vendor keeps coming up with new versions to fix bugs, solve user issues, and make sure that the software is compliant with any government regulations that you might be using it for. Works best for applications that offer few competitive advantages. Or sometimes the competitive advantages is how you actually just function using the software. If your 2B process is better than even the software, go for it. Cons, it might not match the organizational requirement, might overstate the product. You might not understand up front. Let me let the phone call go away. It's a robocall, obviously. You might overstate the product's capabilities and the vendor support you're thinking you're going to get, and you become sorely disappointed afterwards. So you got to make sure that's all contracted properly. Requires an organization to change business processes and develop interfaces. I think any significant software implementation requires you to review your business process and update it. I'm sorry, I think that has to happen in both cases. May not include new features needed by the organization. Well, if it does, that's a problem. If it has features you're not going to use, that's not really a problem. It may not fit the enterprise architecture. If you're using SAP or Oracle, it might not clamp on, even though I think that's less and less a problem these days. Most applications I've seen, it's easier to use prepackaged. Now, if you're doing an app for your specific business, even then you could have your own app and design your own app. But I think even other apps are generally adaptable to make it look like your own app. You're using someone else's app, but it looks like it's yours. One example of that would be, there's softwares out there for looking at jobs and handling resumes, and you could go to the website itself for the company and do a general job search, but the software is also bought by companies, and this company will come in and say, use our software instead of yours. Don't develop software. We have one. Put all your resumes, all your job portals, everything goes through us, but it looks like it's part of your company and your website, and we'll do all the back office work for you. And I think that's the way the world is moving and has moved. So Waterfall, we talked about that a little bit. It's still widely used, but I really think that the iterative way is the way most people look at things. I mean, there's specific periods where you might have a sign-off for this. There might be a specific sign-off for this that we're officially in this stage, but you're still going to use some of these skills and stuff. There's a specific, start and end to development before go live. But even then, there's going to be development work happening after that, but you classify it as something else. So you can have the best of both worlds, I think. And we'll talk about that more perhaps in the project management next week. The buy strategy, advantages and disadvantages. I think we talked a little bit about that. You have some planning, you have some analysis. Do we build it ourselves? No. If not, you go to RFP, you do a vendor evaluation, contract negotiation and signing, customized implementation, maintenance. And the customization is probably minimal. If you do it yourself, then you go through the regular software development lifecycle: design, develop, test, implement, maintain. So that's kind of the flow chart of that. And what's an RFI? Is a request for information. It's a request sent to any vendor, but in this case a software vendor, containing high-level description of the information system an organization needs so that the vendor can describe their products that may fit. So RFI, request for information. Request for proposal. Well, after you got the information, you've probably redefined your needs based on what you learned from all the different vendors that you got information from. So it's an invitation to software companies to submit a formal proposal, including a detailed description of their product, service, and costs. RFP details the requirements developed in the analysis phase and also includes information about the organization's architecture, staffing, and other relevant details, including support after you go live. Then there's a concept of best in breed, an approach used by organizations which they procure the best systems for each application, regardless of the vendor, and then build interfaces amongst them. Yeah, I'm not sure about that either. I think if you go with an ERP structure, I think Oracle and SAP have worked to try to make their offerings in each of the ancillary parts, outside of the main part of their ERP, which is general ledger, order management, and planning, which is production planning, procurement planning, and material planning. I think all the ancillary ones, which would be the transportation management, warehouse management, quality management, HR function, blah, blah, forecasting, I think they've all bought other companies that they considered best in breed and continue to try to maintain that. So there's always a trade-off for best in breed versus how well and easily it integrates. And that trade-off doesn't go away. Evaluating the options. So you can look at, you need some table. Basically what they've done is a weighted option of commercial software vendor 1, 2, and open source solutions and software as a service. They looked at does it match our requirements and rated it from, on a 1 to 5 scale, 1 very poor, 5 very good. Vendor experience of working with our kind of industries, so they've done that. References of vendors, vendor architecture, cost of the system, and then they come up with a total, and the higher being the better, which means they should go with software as a service based on this analysis. Or, as is sometimes the case, senior management has decided we're going to go with SAP. And your job is to implement it. Well, okay, thanks. We're going to avoid this. Or we're going to use Oracle because my best friend, that company XYZ that we don't actually compete with, thinks Oracle is the best thing since sliced bread. Okay, let's do that. It's rare that you have to go through this kind of detail, but when you do, and maybe in the government and a lot of military applications, you've got to go through this kind, but there's still a bias by the management of what they think the solution is or will be. And then adaptation and customization. Allow me to wax eloquent a little bit, or not eloquent, on this. In the early days of ERP system, everybody thought, my company is different. We have to implement, we're going to implement this software, but you've got to make, we don't work like other companies. Our company is unique. We make pens, we make toothpaste, we make cereal, we make this, that, the other thing. And our company culture is different. The way we structure everything is different. And so everybody insisted on customization of SAP software. They learned a very rude lesson the first time they came up with a revision. Their customized coding did not pass through to the revision. The base level SAP and Oracle functionality in revision 2 were there. So they had to go back and invest all this money to customize it again. And all of a sudden, when they realized that, maybe we're not so unique to everybody. The business processes, our processing an order is processing an order. What makes our company different is maybe we can process it faster. Maybe we process it more effectively. Maybe we have less errors in processing it. Whatever the case may be, it's not the software process so much, but your own business process and how you run it and how you adapt the software to you. So adaptation became the rule of the game more so than customization in most business areas. And then the human part. I've been talking about the human part through the whole thing. This is a socio-technical system. You need people involved. And you need the base user has to see value in the new system. It's change. If you have someone that was really, really good, a power user in the old system, you've now threatened them by putting in a new system that made them, that were in the previous system, they were expert. They may not be an expert right away in the new system. That change causes stress in people. And people are what my buddy called cave people, citizens against virtually everything. There's a whole class of people like that. You want to find the folks and ride the horse of the folks that are looking for change, looking to make things better. And that's a smaller percentage of the people. Senior management, especially if you're talking about a full ERP implementation, has to be involved. Without them, it doesn't happen very effectively. They've got to hold people's feet to the fire. Because basically during an ERP implementation, you're just basically burning money. And you got to be very careful about that. And consultants, when you hire consultants, sometimes are really, really important and can make things better, faster, quicker. But there's like a regulatory capture almost here in that the consultants can take over your project. Remember, don't let the IT people take it over fully. It's a business project. A business lead has to be in charge. IT is a very close second, but secondary. Consultants are there to help you, not to tell you what to do. Now, they may know more about the software and have probably implemented it several more times than you do, but you're a quick learn. So remember, they work for you. You don't work for them. Sometimes that gets very fuzzy. And, those are the kind of things I guess I want to tell you. So we talked about system development lifecycle and development strategies, what strategy to use, do build and buy, and we talked a little bit about the human element. And next time, we're going to talk about project management, because in any significant software development and or implementation, it ends up being a project and has to be managed like a project. So we'll talk about that next week. Thank you very much.